all in your very own faculty-driven institute, Resultant. Hope you guys are fine. So guys, I'm standing slightly away from a factory outlet. Actually, I wanted to show you the type of plume. If you can check it out there, zoom it once. So you can see there, a Coning Plume is there. Right now, the wind velocity at present where I'm standing is greater than 32 km per hour. So the type of plume which is being liberated, just check it out there. It is a Coning Plume, and I guess you guys know that Coning Plume is formed when ELR is less than ALR, that is environmental lapse rate is less than adiabatic lapse rate. So just check it out that due to the effect of wind velocity, here you can see that a cone-like formation of the gas which is being emitted is being done. Now let's go to the studio and study in detail about Coning Plume.
Hello, my dear students. Welcome you all to your very own faculty-driven institute, Resultant. So, guys, now quickly, as you have seen the Coning plume, let us talk about how does this Coning plume gets formed. What are the various terminologies which in extra you should know about it? Okay. So, first of all, let me tell you that welcome back again. And if you are new, then kindly subscribe it, like the session, and share it with maximum of your friends. So this is Sandika Funda with you guys. So before that, if you don't know about me, you can go through my profile. And now if I talk about Coning plumes, so first I should know what do you mean by plumes. So as you can check it out in this diagram, the dispersion of the gases, that means from the source of the production, whatever the dispersion of gases takes place, that is known as plume. And the source, like let us suppose it is getting formed, getting emitted from the chimney. So that will be known as the stack. So the source is known as stack. Okay, so the dispersion of the emitted gas from the source of the production, you will call it as the plume, and the source you call it as a stack. Okay, that's why in some places you see that they call chimney also as stack. Now, if I talk about next, as I told you about Coning plume, but before that I have to tell you about what is ELR and what is ALR. First of all, this is the official denotions. Next is environmental lapse rate, which you also call it as ambient lapse rate. Now, what happens whenever you talk about lapse rate, you know, in troposphere, as the altitude increases, that means as the height increases, the temperature decreases. So the rate of decrease of temperature with increase in altitude is known as lapse rate. Correct. Now, when you talk about environmental lapse rate, the temperature of the surrounding air decreases with increase in altitude is known as environmental lapse rate. Now you will ask me that, ma'am, how could I know that you told that with increase in altitude the temperature of air is decreasing, but how can I know this? So guys, let us suppose surface is there. You have put a balloon. Okay, you are having a balloon, and with you have inserted a thermometer. You have inserted a thermometer. A self-recording mechanism is there. So in the ground, you would have measured the temperature, and as the balloon is getting lifted, the thermometer is also going with it. So at various altitude, at various height, the temperature is also being monitored. A self-recording mechanism is there. So you will see that with the increase in altitude, the temperature of the surrounding air decreases. So the rate of decrease of temperature with temperature of surrounding air with increase in altitude is known as environmental lapse rate. Now you will say, ma'am, is it constant? No. ELR changes from place to place. So for let us suppose if I am in Lucknow, you are in Delhi, I am in Bhilai, you are in Mumbai. So the environmental lapse rate doesn't remain constant because the ambient air changes, right? The surrounding air will change. Because of that, you will not find the environmental lapse rate to be constant. Next, if I talk it about is adiabatic lapse rate. Now, when I talk to you right now, I talk to you about the surrounding air. But let us suppose if I take a car, this is my car and nobody will laugh. Huh? This is the car which is emitting the pollutants. This pollutants you call it as air parcel. Air parcel means the pollutants. So it has been seen that the pollutants also, when they rise up, so when they rise up, that means when the altitude increases, the pollutants also temperature decreases. Now you will say, how come decreases? Okay, because the meaning of adiabatic is that there is no exchange of heat is taking place. So how could the temperature decrease with increase in altitude? Can you tell the reason for this? So if you go flashback to your chemistry, you remember PV to the power gamma is constant. Now, as it is going up, the temperature is reducing. Okay, so the pressure is also reducing. Correct. Now, PV to the power gamma is constant. To maintain this constant, the volume has to increase. Now, if the volume is increasing, now first of all, the question comes how the volume will increase. The pollutant will utilize its own internal energy to increase the volume, and if the volume will increase, you will see that the temperature decreases. Okay, so as you move up, the pressure will be decreasing. You know that whenever you climb the mountains and all, you see that the pressure decreases. So similarly, when this air parcel pollutant will be going up, you will see that the pressure is decreasing. But PV to the power gamma is constant. So if pressure is decreasing, the volume has to be more, so that the multiplication of it gives you a constant value. Volume will increase when this pollutants will utilize its own internal energy. Why, ma'am? Why can't it take it from other places? Because this is an adiabatic process. So no, there will be no exchange of heat from anywhere else. So it will utilize, the pollutant will utilize its own internal energy, and the volume will increase, because of which you will see the decrease in temperature. So that is the reason for pollutants also. As you rise up, what will be happening? There will be what? There will be the decrease of temperature taking place. So the rate at which temperature of the pollutant decreases with increase in altitude, you will call it as adiabatic lapse rate. Now what will happen is, now what will be happening is, there are different types of plumes. You classify them based on ELR and ALR. Okay, now here we have to talk about Coning Plume. First of all, you will be calculating it when the horizontal wind velocity will be exceeding, or basically it should be more than the 32 kilometer per hour. Now the other thing about it you should know, that here if I talk it about under sub-adiabatic condition, that means when ELR is less than ALR, you will see that there will be vertical mixing will be limited, and you will see that in Coning Plume the environment will be slightly stable. Okay, and as you know that it attains a cone-like structure, which I have shown you practically, so it will call an Coning Plume, and this will take place when ELR is less than ALR. And let me tell you, when ELR is less than ALR, that means when environmental lapse rate is less than adiabatic lapse rate, you get a stable environmental conditions. Mixing of the pollutants will not be there. So this we will classify it as a stable condition. Okay, so now I guess you got the logic. What is ELR? What is ALR? How does this Coning Plume takes place? Okay, so this was all about your Sunday Ka Funda video, guys. And if you want me to make video or any other topic, kindly comment it on the comment section. Thank you, everyone.